Okay, so today we're going to learn logarithmic functions. Learning goals for today is to determine if a function is a logarithmic function or can be obtained by transforming a logarithmic function. And sketch the graphs of logarithmic functions and understand and interpret the main properties of logarithmic functions. Okay, so just like what we have done in lesson 1 of unit 3, first of all, we'll have a look at the sketch of the graph of logarithmic functions and as well as and the main properties. Okay, so a logarithmic function has the form y equals log base b of x, whereas b is greater than 0 and b is not 1. So there are two cases of the sketch of the graph of logarithmic functions. If b is above b is greater than 1, this function will be an increasing function like this. It crosses the point 1, 0. This is a point 1, 0. And x equals 0 is vertical, it's vertical asymptote. And if b is between 0 and 1, this function will be a decreasing function, also crossing the point 1, 0 here. And y equals 0 is its vertical asymptote. So logarithmic function is the inverse of the exponential function, y equals bx. So these two functions is symmetrical about the line y equals x. So as you can see here, this function here is y equals b to the power of x. And this function here is y equals log base bx. These two functions are the inverse of each other. So these two functions must be symmetrical about the line y equals x. And in the other circumstance, you can also find that these two functions are also symmetrical about the line y equals x because two functions are the inverse of each other. Okay. And then the logarithmic function has a domain x belongs to real number set and x must be greater than 0. Okay, it's not defined in the left side of the x-axis. X here must be greater than 0. The range is a whole real number set and it has a x-intercept of 1, 0. Okay, it crosses the point 1, 0 because when x is 1, the log base b of 1 is 0. And we have just mentioned this. It has a vertical asymptote at x equals 0. Okay. And because it's the inverse of the function y equals b to the power of x, so it's symmetrical about symmetrical with y equals b to the power of x in the line y equals x. Okay, so these are the main properties of these functions. Here are some examples. The left graph shows that when b is above 0, this function will be an increasing function, crossing point 1, 0. And when b is within 0 and 1, you can see here, this function is a decreasing function. Again, I need to mention there are two special functions. One is y equals log x. When we don't write the base number here, by default base number is 10. Okay. And another one is y equals line x. This means log ex. The base number is e, which is approximately 0.72. This is an irrational number. Okay, these are two special cases for the logarithmic function. All right, so next let's have a look at the transformations of logarithmic functions. Just like other functions we have discussed in chapter 1, the logarithmic functions can also be transformed by using this transformation theory. Suppose we have a rational function fx equals log base x of x, log base b of x, and then we can transform this function to a times fk times the difference between x and d and plus c. The 4 parameters here correspond to 4 types of transformations. A corresponds to a vertical stretch or compression, and if A is less than 0, a reflection in the x-axis. And K corresponds to a horizontal stretch or compression, and if K is less than 0, reflection in the y-axis. And C corresponds to a vertical translation up or down, and D corresponds to a horizontal translation to the left or right. And then remember to do the translation reflected by A and K first, and then followed by D and C, okay? All right, so let's have a look at an example. State the transformations needed to get a graph of y equals log base 10 of x minus 2 and then minus 5 from the graph of y equals log base 10x. B, sketch the graph of y equals log base 10 of x minus 2 minus 5. C, state the domain range x-intercept, y-intercept equations of asymptote of the new function. Okay, I'll give you 5 minutes to think about this question. All right, let's have a look at the solutions together. So first of all, this function is log base 10 of x minus 2 and then minus 5, right? So the first parameters is here minus 2. This corresponds to a horizontal translation to the right by 2 units, right? And then minus 5 here corresponds to a vertical translation down to 5 units. So first of all, we can apply the horizontal translation first. That's 2 units to the right. And the graph of this function is moving from the red curve to the blue curve here, right? And then we can apply the vertical translation down by 5 units. Then it moves from the blue curve here to the green curve. And the green curve is a graph of the function y equals log base 10 of x minus 2 minus 5. This is a curve we want here, right? And originally it crosses the point 1, 0. And after the first translation, this point moves to apparently 3, 0. And after the second translation down, this point moves to the point 3 minus 5, right? So it must crosses the point 3 minus 5. And the vertical asymptote moves from x equals 0 to x equals 2. This is a new asymptote, right? Right, so the domain now is x belongs to any real number, but x must be greater than 2. The range is, of course, same with the original range, which is the whole real number set. The x-intercept occurs when y equals 0, as we said. So the x-intercept is, if you solve this question, you can find that the x-intercept is 1, 0, 0, 0, 2. And the y-intercept occurs when x is 0. But if you put x be 0 into the equation, you can find that log minus 2 is not defined. So there's no y-intercept, right? And as we said, the vertical asymptote occurs when x minus 2 is 0. Thus, the vertical asymptote is now at x equals 2. Okay. Okay, please have a look at the solution here. Any question, let me know. All right, if no questions, let's have a look at another question here. State the transformations needed to get a graph of y equals 5 times log base 10 of x plus 3 from the graph of y equals log base 10 of x. And sketch the graph of the new function. State its domain, range, x-intercept, y-intercept, equation of asymptote. Okay, again, I'll give you 5 minutes to think about this problem first, okay? All right, so let's have a look at the solution of this problem. Okay, so basically there are two parameters, right? First parameter corresponds to a stretch vertically by a factor of 5 here. The second parameter here is actually x minus 3, right? So it corresponds to a horizontal translation, 3 units to the left. So first of all, we need to apply the vertical stretch first. The original graph is the red curve, which is y equals log base 10 of x. And then if we stretch vertically by a factor of 5, the new graph also crosses the point 1, 0. This is not this does not change, right? The only change here is the original curve is stretched vertically by a factor of 5. So it becomes the blue curve as shown in the graph here. All right. And there is no change to the asymptote. Asymptote will remain at x be 0 at this stage. Okay. Once we have done the vertical stretch, next we can do the horizontal translation. Horizontal translation is 3 units to the left. So this new graph now will cross the point -2, 0 here. And the asymptote will move from x be 0 to x be -3. Okay, so if we summarize, the domain now is x is greater than 3. The range is the whole real number set. This does not change. And the x-intercept is we let y be 0, solve for x, which is -2, 0. Y-intercept is when x is 0, we solve for y, right? So when x is 0, y equals 5 times log 3, which is 5 times log base 10 of 3. So the y-intercept is 0 and 5 times log base 10 of 3. And asymptote is now x equals -3, okay? All right, so please have a look at this solution. Any questions, please let me know, okay? All right, so if you don't have any questions, let's see another practice. In state transformation needed to get the graph of y equals log base 10 of -2x plus 4 from the graph of y equals log base 10 of x. And then sketch the graph. State its domain, range, x-intercept, y-intercept, and equation of asymptote. Okay, I'll give you 5 minutes to think about this question first. Okay, so have we finished? Let's have a look at the solutions together, okay? All right, so basically there are two parameters. One parameter is k, which is -2. That corresponds to a horizontal compression factor of 1/2 and a reflection horizontally in the y-axis, right? So the second parameter is the parameter c here. That corresponds to a vertical translation up by 4 units. So remember, we need to do the horizontal compression first. So first of all, we can apply the horizontal compression from y equals log base 10 of x to y equals log base 10 of 2x. The anchor points moves as follows: from 1, 0 to 0.5, 0. And 10, 1 moves to 5, 1, right? And the asymptote will remain at x be 0 at this stage. And after that, we can reflect the graph in the y-axis to transform y equals y equals log base 10 of 2x to y equals log base 10 of minus 2x. So the curve now becomes the green curve here, okay? And the two anchor points moves from 0.50 to minus 0.50, and from 5,1 to minus 5,1. After that, we can finally apply the vertical translation up by 4 units. So the two anchor points moves to minus 0.54 and minus 5,5, as shown in the blue, in the purple curve here. Okay, the purple curve here is a final graph we're looking for. So now let's summarize the domain and other properties. Domain is minus 2x must be greater than 0, right? So that means x is less than 0. The range is the whole real number set. X-intercept, we can just let y be 0 and solve for x, which is x be minus 1/2 times 10 to the power of minus 4. Y-intercept, we can just let x be 0 and solve for y. Apparently, if we let x be 0, y is undefined, so there is no y-intercept. Asymptote, the position of the asymptote does not move, so asymptote is still at x equals 0. All right? Okay, so please have a look at the solution, and if you have any questions, just let me know, okay? All right, if you don't have any questions, let's have a look at another practice question. Now the function becomes y equals log base 10 of 2x minus 4. State the transformation needed to get graph of this function and sketch graph it sketch the graph of this function and state its domain range x and y intercepts and equation of asymptote. Okay, I'll give you 5 minutes to think about this question first. All right, so let's have a look at the solutions together. So first of all, let's convert this this function to log base 10 twice of the difference between x minus 2. So there are two parameters, right? First parameter corresponds to the parameter k, which is a horizontal compression by a factor of 1/2. Second parameter is x minus 2. So 2 minus 2 here is the second parameter, right? This corresponds to a horizontal translation 2 units to the right. So first of all, remember we need to do the translation corresponds to the k first and apply the horizontal compression first from y equals log base 10 of x to y equals log base 10 of 2x. So the anchor point moves as follows: from 1, 0 to 0.50, and from 10, 1 to 5, 1. And of course, the vertical asymptote will remain at xb0 at this time. Next translation is to apply the horizontal translation to transform the y equals log base 10 of 2x to y equals log base 10 of twice of difference between x and 2. So the anchor point now becomes 2.50 and 7, 1. And of course, the vertical asymptote has also shifted to the right to x equals 2, as shown in the green curve here. The green curve is a final curve we're looking for, right? And now let's look at the domain. Domain is 2x minus 4 must be greater than 0, right? So that means x must be greater than 2. This is our domain. Range, of course, the range is the whole real number set, which is negative infinity to positive infinity. And then x-intercept, we can just let y be 0 and solve for the x here, which is 5/2, 0. And y-intercept, we can just let x be 0 and solve for y. If we let x be 0, you can see that this number here is actually negative, right? So log base 10 of a negative number, this is not defined, so there is no y-intercept. And also, as you can see in the graph, there is no intersection between this curve and y-axis, so there is no y-intercept. Asymptote, as we have just mentioned, asymptote moves to x equals 2 now, okay? All right, so please have a look at the solutions here. Any questions, please let me know, okay? All right, so let's make summary of today's lesson. Today we have studied the logarithmic function. Now you should be able to determine if a function is a logarithmic function or can be obtained by transforming it, by transforming a logarithmic function. And you should also be able to sketch graphs of logarithmic functions and understand and interpret the main properties of logarithmic functions, okay? Okay, so tomorrow we'll do a practice test. Tomorrow is our lesson 4 of unit 3, right? So in unit 3, lesson 4, we'll do a practice test. This will not be marked, it's just a practice and get you prepared for the assignment 3, okay? So basically I'll give you a list of questions for you to solve in the first half of that lesson. And after that, we'll have a look at these solutions together. And in Unit 3, Lesson 5, we'll do assignment 3. Okay, so please get prepared and use lecture slides and your homework for each lesson as the review materials. Okay. All right, so the rest of the time is for you to complete today's homework, and do remember to submit them onto Google Classroom before the deadline. Okay. All right, so you can start now.